Methods of forensic schedule delay analysis. Construction projects have their own typical problems resulting in construction disputes. It is obvious that time is one of the most important components of a construction product. If it is not used efficiently, delays and time overruns will occur. These delays may have cost impacts on the project, and both the contractor, subcontractors, and the client might be affected. Therefore, forensic schedule delay analysis methods are applicable for resolving disputes between the parties of the construction projects. When delays happen, schedule delay analysts bear the burden of selecting the appropriate schedule delay analysis methodology to analyze and quantify schedule delays and concurrent delay. However, selecting the most adequate schedule delay analysis methodology remains a subject of controversy. What are the forensic schedule delay analysis methods? In order to determine the delays in a construction project, you must employ forensic schedule delay analysis methods. Simply put, delay analysis is a process of answering the questions: how late is the project? What has caused the project to delay? Who is responsible for the delay? What is the cost impact of the delay? Is this a concurrent delay? Project duration and delays can be calculated with the help of the critical path method. Forensic schedule delay analysis is the investigation of tasks and activities by using CPM scheduling methods to model the real project situation to resolve delay claims through negotiations or legal processes. Although there are several approaches for performing construction schedule delay analysis, there is no standard method. Association for the Advancement of Cost Engineering AACE recommended 9 method implementation protocols for delay analysis. Other related associations and professionals recommended several methods for this purpose. There are 4 commonly used methods for forensic schedule delay analysis: as-planned versus as-built analysis, windows analysis, time impact analysis, collapsed as-built, as-planned versus as-built analysis. As-planned versus as-built analysis is widely used for the comparison of the plan and the actual performance of the work. The dates and durations of the activities are selected from the baseline schedule and compared with the actual schedule. The main benefit of this method is that it is easy to perform and understand. Many experts use this method because of its simplicity. Below are some limitations of as-planned versus as-built analysis. Concurrent delays cannot be measured. The logic in the sequence changes as the work performed, but this method ignores this fact. It is not easy to implement this method in complex projects. Windows analysis. In the windows analysis, the overall schedule is divided into windows with a selected duration. Then the activities within the selected window are updated by the expert considering the delays. Responsibility for each delay is determined by analyzing the windows. The windows analysis method provides precise information regarding the delays when there are regularly updated CPM work schedules. It is difficult to manipulate. Below are some limitations of windows analysis. The work schedule may not be updated regularly with correct dates. The baseline schedule may not be prepared accurately. Activities outside the selected window may have impacts on the activities inside the window. Time impact analysis. Time impact analysis is a delay analysis method that considers the cause and effect of a change to a critical path method (CPM) schedule. An event that causes a delay is identified and its relationships with the activities are determined by using this method. Time impact analysis is a useful technique for analyzing complex schedules and determining concurrent delays. This technique is accepted by many courts and agencies. However, it has some limitations. Below are the limitations of time impact analysis. Can be expensive and time-consuming. Can be susceptible to manipulation. Collapsed as-built. In this method, the expert uses the actual as-built schedule and takes out the duration of all the delays attributable to the contractor. The as-built critical path is determined by analyzing the activities of this revised schedule. Collapsed as-built analysis is a useful technique for determining concurrent delays. Below are the limitations of collapsed as-built. Preparing a revised schedule is time-consuming and expensive. Manipulations can be made while making the revised schedule. The expert must make substantial decisions. Like other resources such as labor and equipment, time can be considered a resource that is spent on building a construction project. Forensic schedule delay analysis methods are closely related to correct CPM calculations. In order to make substantial CPM calculations, the baseline schedule should be prepared properly. The choice of the adequate schedule analysis method depends on data availability, contractual requirements, time of the analysis, costs, and level of effort, among other factors.